We're going to be evaluating some logs, and in order for us to evaluate logarithms, we do need to know a couple of properties. Here's the beginning of the two we are going to be using. If you have a log and it has a base, in this case we're generically calling it base b, but this value here, the base of the log, is going to be a positive number but not equal to 1. If the base of the log is equal to the base of the exponent, then the log and the two bases will end up canceling out, and this will simplify just simply to x. So we have a log with a base. We have an exponent. The exponent is x, and the base of the exponent is b. If the log's base and the base of the exponent are the same, then essentially those things cancel out and we just get the exponent for the answer. Similarly, in the other property we're going to be using, if you have the base of the exponent, so here we have b raised to a power, so the base of the exponent is b, and up in the exponent we have log of base b. Again, similarly, if the base of the exponent and the base of the log are the same, then that will simplify to just this value here, which in some textbooks is called the antilog. All right, so let's take a look at how this would work. If you have, for instance, log base 6 of 6 to the 4th power, and you're going to simplify that. The base of the log and the base of the exponent are both 6. So this is simply equal to the exponent. That is equal to 4. Sometimes the base of the log and the base of the exponent won't match. So right now I have log base 3 of 9. There really isn't an exponent written in there, but that is an invisible 1. So it's log base 3 of 9 to the 1st power. The base of the log is 3, but the base of the exponent is 9. Those numbers do not match. If that happens, you're going to want to try to take the base of the exponent and see if you can write it so that it matches the base of the log. So in this case, I can rewrite this 9 as 3 to a power. I can rewrite this as 3 squared. 9 is the same thing as 3 squared, and now I have a situation where the base of the log and the base of the exponent do match. So I can use that property and simplify. This one is a similar idea, but a little bit harder. I have log base 5 of 1 over 125. What I want here is I want 5 to a power. So what I need to do is I need to take a look at that 1 over 25 and ask myself, 5 to what power is equal to 1 over 125? Well, I do know that 5 to the 3rd power is equal to 125. So what that means is we would need a negative exponent here in order to get its reciprocal. 5 to the 3rd power is 125. 5 to the negative 3 power would be 1 over 125. And that is what we have here. So we can rewrite 1 over 125 as 5 to a power. So this is log base 5 of, and 1 over 125 is 5 to the negative 3 power. So I was able to write our number here so that the base of the log and the base of the exponent matched. And now we can use this property once again to simplify that down. If there's no number written next to the log as the base of the log, remember that that is log base 10. So this really is just log base 10. It's just when we have log base 10, we don't have to write the 10 in. So even though it really didn't look like it, the base of the log here and the base of the exponent already did match. We just have to recognize that if you have log, it is technically log base 10. If you have a log of a decimal, you can do that a few different ways. One of them would be for you to recognize that this decimal could be written as, if I move the decimal over 5 places, it could be written as 1 times 10 to the negative 5th power. And 1 times 10 to the negative 5th power is the same thing as 10 to the negative 5th. So this log could be rewritten as log, and it is log base 10. So we have log base 10 of 10 to the negative 5th power. So the answer to that one is negative 5. Log base 7 of 7. Well, if there's no exponent here, it is a first power. So technically, this is log base 7 of 7 to the first power. The base of the exponent and the base of the log do match. That seems like that should be obvious, but sometimes as we're going through and doing these problems, that's not always an easy thing to notice or to see. Log base 4 of 1. The base of the log is 4. And what I want to have here in place of that 1 is 4 raised to a power. So the question becomes 4 to what power is equal to 1? Well, anything to the 0 power is equal to 1. So you can take the 1 that's here and rewrite it as 4 to the 0 power. So this would be log base 4 of 4 to the 0 power. So using our property, we would end up with 0 for an answer on that one. The natural log of e to the 5th. It doesn't look like it, but we already have the base of the log and the base of the exponent matching. Remember that natural log is log base e. So we have log base e of e to the 5th. So the base of the log and the base of the exponent are both e. So we can use the property directly in order to come up with an answer on that one. If you had 2 times log base 5 of 5 raised to the 9th power, we can use that property to simplify that as well. We have, in this problem, nothing in between the 2 and the log, so there is multiplication there. But if we simplify using the property log base 5 of 5 to the 9th power, we can see that that's going to give us 2 times, and then log base 5 of 5 to the 9th is 9. So we do end up with 2 times 9, or 18, for a solution on that one. This whole way through, we've been using one of 2 properties. But there are 2 properties that we talked about at the very beginning. Most of the time we do the first one, the one that we've been working on through all 9 of those previous problems. This is the other property that we wrote down at the very beginning. If you have the base of your exponent raised to a log power, and the base of the log matches the base of the exponent, then all of those things do cancel, the bases and the log. So this is going to just simplify to the number 4. So that's how you use the other property from that section.